Thanks for the intro, Emily, and thank you all for the time today. Can you hear me okay?
Yep.
Okay, awesome. So thanks for joining, everyone. My name is Osama Ahmad. I'm with the C2000 Real-Time MCU product marketing team here today, along with Shamim Chaudhry, who is our digital power systems expert. Today, we'll walk through an overview of C2000 real-time microcontrollers, specifically diving into our latest device to release to market and also our lowest cost device to date, which is the TMS320 F28002X. But first, we'll start with a C2000 overview. Like I said, we'll go into the F28002X family, talk through how it fits within our Generation 3 portfolio of devices and what Gen 3 devices families actually are and what that means. And then I'll close with how you can easily get started with development on these devices and all the tools, software, some reference designs, and other material to get you up and running. And then for the second part of the agenda, Shamim will talk through how C2000 and our latest TI GaN technologies are addressing these growing design challenges of maximizing power efficiency and density while helping save system size and cost. So he'll also touch on a number of TI GaN and C2000 reference designs. Awesome. So let's jump in. So first of all, where do you see C2000 real-time MCUs? And the simple answer is really anything that requires power conversion or motor control. Of course, that spans kind of a wide range of applications. We've been in the market for the past 25 years in industrial and automotive. So it started within motor control applications, and from there, we got into power supply and other digital power applications, especially as the market starts demanding, higher power efficiency, especially in these power delivery server PSU type of applications where digital power control brings real differentiation. So C2000 maintains a strong position in those areas, as well as solar inverters, energy storage, EV charging station infrastructure. And now with C2000's wide portfolio, it tends to naturally span more applications than just these, especially with the expanding portfolio. But these are just some key ones where we see the real value of C2000 real-time control in effect. And all of these, again, are based on energy conversion, which is what we hang our hat on. So here's a slide that I feel tells the story of a C2000. So this seems like a busy slide, but long story short, C2000 is a portfolio of scalable, ultra-low latency real-time controllers that are designed for power electronics. So C2000 can be looked at as having three essential blocks: sensing, processing, and control. And all of these are critical for a real-time control system. And the device is built to minimize the time it takes to sense something from the outside world, perform some calculation on it, and actuate your control system. And out of those three key blocks, though, there's some more differentiation and outlets to lower system cost and bring in some system integration through communication and interface peripherals. And behind it all, kind of the foundation behind all this is our 25 years of systems and device expertise. So not only are we able to release these devices, but we have the knowledge base to support various software libraries, reference designs, and other solutions that are targeted for these kinds of applications. All right, moving on to the real-time control makeup of what differentiates C2000. This slide kind of shows, moving left to right, the trends and demands of the power electronics world. These are things that we're seeing now and that we'll continue to see. Things like efficiency, integration, and performance. So really, to complete the story on purpose built for real-time control, the bottom part of this slide kind of reiterates the message of minimizing the time between your ADC interrupt when you sample an input to sending a signal through the PWM output, specifically looking at the control algorithm side. So we've done some benchmarking to show that this area labeled number 4, which is the block that represents when your processor is performing some calculations on an input. An ARM-based architecture would need to run at about twice the speed to achieve the same tasks in about the same amount of time. So you can see that with the efficiency of the C28X core, the time between sampling and output is still smaller, running at 200 megahertz compared to an ARM core running at about 400 megahertz. So it's a major differentiation, speaks to the point of real-time control. Okay, so getting into F28002X, here in the roadmap, this is a picture of our portfolio split by Generation 2 and Generation 3 device families. So going up and down on the y-axis, you have performance and features. So we have a portfolio that scales from low end to high end, all while maintaining that code and peripheral compatibility to make it as easy for developers to scale their platforms with minimum effort. And on the x-axis is time. So you'll see our first wave of Gen 3 devices like the 004X and the 07X on the mid-end side, and with F2837X on the higher end side. You'll see our latest, most cost-optimized device, the F28002X on the low end, and our highest end device, the F2838X, which have both released to market and are in production this year. And the roadmap doesn't stop there. We're making efforts to expand further into the low end, mid end, and high end side. So like I mentioned, a series of products from high end F2838X that has 2 C28Xs and 2 CLA coprocessors for more than 800 MIPS, scaled down to the F28002X that has 1 C28X core running at 100 MIPS. And the idea is that you can start development with one of these and adjust accordingly because of the flexibility through the peripheral and the code compatibility that you get. And we'll get into what Generation 3 actually means. So let's keep the ball going here. So F28002X applications. Here's some deeper insight into specific end equipments or applications where the performance to cost ratio and the feature set has a strong play. By no means is it limited to just these, but a few worth calling out for sure. On the motor control side, applications like single axis servo drives, variable frequency drives, and appliances. And then on the digital power side, on the power delivery side, things like server and telecom power supplies for either or both PFC and DC-DC control. Onboard chargers, high voltage to low voltage DC-DC converters, and traction inverters for EVs, and a variety of solar inverters like string, microinverters, and MPPT DC-DC boost converters. Okay, here is a chip block diagram of our F28002X device. It's a 100 megahertz C28X CPU device, giving a total of 100 MIPS. It's enhanced with the TMU, which is the trigonometric math unit, as well as the FPU, which is the floating point unit. Comes with 128, 64, and 32K flash options with 24K RAM. Also contains the CLB, or the configurable logic block, for that additional peripheral customization and ability to enable other functions like PWM protection and other things. It has 2 12-bit ADCs with a total of 16 channels, 4 comparator subsystems, 14 PWM channels, with 8 of those having high resolution capability. So we're talking 150 picoseconds of resolution. And depending on the package type, you're running between 14 and 39 GPIOs. And then from a comms and interface standpoint, the device has PM bus, CAN, I2C, SPI, SEI are all available, along with our proprietary fast serial interface, or FSI, that runs up to 200 Mbps across isolation. Okay. Going into the Gen 3 enhancements, so this is including the F28002X here. So this is not an extensive or complete list by any means. It's kind of meant to be a high-level overview of these key enhancements. Ultimately, it's a higher performance and lower cost migration from the Gen 2 devices. And we've added features to boost performance significantly, like the FPU, the floating point unit that I mentioned, the TMU, and the DMA. We also have improvements to the sensing capabilities with more ADCs, new comparator subsystems, new IP that we're introducing, like the host interface controller, or HIC, and a variety of new and improved communication peripherals. So on the table here, you'll see a feature set comparison between the F28002.5 and the 0049 Hero mid-end device, and also a few of our key high runners on the Gen 2 side, the F28027 and the F28035. And this table will be available in the getting started material that we provide as well. And a few more points here on the Gen 3 enhancements. Again, overall, the new process technology allows for more to be on the device while consuming lower power. And this table kind of highlights the different improvements added for the particular IP or module within the C2000 device. So I've highlighted a few of these already, like the CLB and the FSI, the configurable logic block, and the fast serial interface. Cool. All right. So getting started, this slide kind of is a care package that includes the bare necessities on how to learn more and to start developing on your platform with the F2A002X. Have included the essentials here, of course, like the data sheet, the TRM, the link to the control card EVM, and the bundle, which is a good point here for me to mention that we do have the F2A002X Launchpad coming next month. Many of you are probably familiar with that Launchpad ecosystem, so be sure to be on the lookout for an even lower cost entry to development there. I've also included links to C2000ware, which is our software and documentation that includes device-specific drivers and libraries and peripheral examples. Also on the software side are our application-specific SDKs. So we have a digital power SDK and a motor control SDK. And finally, some other helpful links that give good insight on how to get started, like the essential guide for developing with C2000 and the 002X product brief. Okay, and here's a couple of just reference designs and more tools that we have freely available on the web. Just a couple I'll highlight here that are supported by F2A002X. This is the TIDM 1001, or the two-phase interleaved LLC. It highlights our Type 4 PWM, ADC, and comparator subsystem features. The hardware and software collaterals and files are all available on the reference design page for this one. And we also have an encoder-based servo drive example based in the motor control SDK. This is a solution for low-cost, single-chip, high-voltage servo drive and features fast current loop FOC. This is also supported by the F2A002X. Okay, that concludes it on my side. We've got about 15 minutes left for Shamim to talk through what problems C2000 and TI-GaN technologies are solving in the market. So Shamim, let me go ahead and pass the ball over to you. All right, there you go.
Could you, Osama, could you show the, you're going to show the slides or?
I just passed presenter control over to you, Shamim. Do you want me to share the slides?
Yes. I thought you were going to keep the slides.
Okay, go ahead.
Okay. Okay, thank you everyone for joining this webinar today. I'm Shamim Chaudhary from C2000 Systems team. So today I'll be talking about how you can use TI-GaN and C2000 microcontroller to maximize efficiency and power density in your power supply design. Here is a, sorry if you missed the first slide. Okay. So here is an, okay, so this is, my name is Shamim Chaudhary. I'm from C2000 Systems. Today I'll be talking about how you can use TI-GaN and C2000 microcontroller to maximize efficiency and power density in your digital power supply design. So here's an example of C2000 and TI GaN-based power converter design. This example specifically shows a 1 megahertz critical conduction mode PFC that achieves 99% efficiency. Critical conduction mode, or transition mode, we call it. This is one of the released digital power SDK that Osama mentioned before. It achieves high power density, significantly higher power density compared to a silicon-based design. What enables this? This is one of the key component is the TI-GaN. TI-GaN provides integrated driver that delivers a much higher speed, twice x the switching speed compared to discrete GaN, and also cut down the losses into half compared to the discrete GaN. GaN provides built-in protection that designed for operation under extreme condition, like overcurrent limit protection. It provides simple interface to the microcontroller, C2000 microcontroller, that simplifies the interface between the controller and the power devices. On the other side, C2000 provides multiple benefits. Fast ADC that provides accurate voltage sensing and fast sensing. It has got powerful 32-bit floating point DSP engine that enables fast processing for any complex power topology like this transition mode PFC or any other multi-level, multi-phase power converter, any PFC or AC or DC-DC or DC-AC type converter. This is not only limited to PFC, but it can be done in any other power converter, any other topologies. Third, the highly flexible, high resolution PWM with 150 picosecond PWM resolution enables high frequency operation. So you can switch the converter at much higher frequency and maintain high resolution of the PWM. That means faster turn off, turn on, and turn off at much higher switching speed. That also reduces the gate drive losses from the control side. On the output side, the drain output capacitance is much lower compared to silicon. That allows for faster switching and higher switching frequencies. That also reduces the switching losses in the device. The conduction losses is also pretty low because of low RDS on. The other feature of the GaN is that it has got no body diode, and so reverse recovery losses is almost absent here. It also reduces the ringing on the switch node because of the reverse recovery process. You'll see in other devices, but in GaN, because of the no body diode, reverse ringing is minimized, and also that also reduces the EMI. Some of the features of TI-GaN is listed here. It achieves twice the switching speed and half the losses compared to silicon, compared to discrete GaN. You can see a switch node waveform here achieves almost 100 volts per nanosecond the rise time, and still the overshoot is less than 25 volts. So this provides highest switching speed in the industry, enabling 50% lower losses in any application, starting from 65 watt to much higher power 10 kilowatt applications. TI-GaN provides high reliability, lifetime reliability. You can see from this diagram here, it maintains very low fit rate, less than 1. If you operate with within the maximum recommended voltage. So it achieves very low failure rate, and it runs for long hours. So this is a robust self-protected solution with 30 million device reliability hours and higher than 3 gigawatt hour of power conversion to date. TI again provides low-cost integrated solution. Here is a diagram of the GAN with the integrated gate drive. You can see it provides simple interface to the controller on the left side, the input signal and the power supply and the fault pins. On the output side, on the output side, you can see the FET and the current sensing. And the FET provides very low RDS on different choices, 50 milliohms to 70 milliohms and 150 milliohms GAN devices, and the current sensing provides integrated protection of the GAN. This is TI own process and manufacturing of GAN FET with integrated driver, and everything comes with protection in a low inductance package. TI GAN plus C2000 provides high efficiency and maximum power density. So here is an example of a silicon power factor converter at 2 kilowatt. TI GAN, because of TI GAN, the switching speed is, or you can increase to switching speed about 10 times higher than what the silicon FET can achieve. 10 times higher switching frequency and reduce the size of the magnetics by 1/5. And on the other side, the controller, C2000 controller at higher switching frequency provides flexible high resolution PWM generation and premium AD converters, enables voltage and current signal sensing, and the processing. Because of C2000, you can process the control loop calculation at a very fast speed and very fast pace, and able to close the loop at much higher frequency. So combination of TI GAN and C2000 provides high frequency solution, high efficiency solution, and reduce the size of the silicon-based PFC compared to silicon-based PFC by almost significantly reduce it, and you can achieve higher power density. So on the right side, you can see the GAN and C2000 based 2 kilowatt PFC full system is almost has 3x power density. Here is another example of a motor drive, silicon-based motor drive at 1.25 kilowatt level. On the left side is a silicon-based design. With the TI GAN, you can achieve much higher efficiency and reduction in cabling and much smaller cabinets. This is an example for a 6-axis motor system. So that's what TI GAN provides the enhancement in this solution. In the C2000 side, again, fast control loop because of the fast processor, and C2000 provides ADC based current and voltage sensing, or also sigma delta based current and voltage sensing. Linear and absolute encoder feedback, industrial low latency communication. Some I mentioned here before. FPGA-like protection, and so that is provided by our CLB control logic block, configurable logic block that provides FPGA-like protection, and for any application that has GAN-based multi-level converters, where you can use the CLB to provide protection for those type of complex power topologies. So if you look at the motor drive solution with silicon and compared to C2000 and GAN-based solution, you can reduce the size of the heatsink almost 85%, and achieve a much smaller and compact design on the right-hand side. this is our TIDM 2008. Has been released. This is a three-phase interleaved totem pole bidirectional PFC, GAN based and C2000 based, rated at 3.3 kilowatt for 230 volt input. It achieves high efficiency and very low THD at 100 kilohertz PWM. Soft starting and for totem pole breach has been implemented. Phase shading and adaptive dead type control for achieving high efficiency. It can run in both CPU or in CLA. The software is available for that, targeted for different types of industrial power supply, onboard charger, energy storage system where bidirectional PFC or inverter is needed. Benefits will be high power density while maintaining OEM specified form factor. Further system integration through latest TI GAN with integrated gate drive enables superior control and implementation of advanced control scheme, and that is enabled by the high performance C2000 microcontroller. In addition to this, we provide power suite solutions, power suite support. Because of the power suite, you can adapt this software for any other design of the same type and customize your software for this any other totem pole PFC of CCM this similar type from the power suite GUI. Here's another example of a bidirectional PFC inverter design. It's a three-phase 900 volt 5 kilowatt bidirectional PFC inverter design with C2000 and TI GAN. Input voltage is up to 1400 volt AC. DC voltage is 1400 volt and AC is 480 volts line to line. Achieves very high efficiency, 99%, no fan. Scalable solution, multi-level solution for up to 5 kilowatt and it achieves low THD. So this is also using TI GAN LMG 3410 series GAN and C2000 controller TMS 320 F28379D. This is also a released design, and it achieves very high frequency and power density. As you can see, the IGBT based solution can be 20 kilohertz, silicon carbide can be 100 kilohertz, but this one runs at 140 kilohertz with TI GAN and C2000 and achieves high efficiency and power density, good power density there. Osama, next. The one before. Okay, so here's some a result from this digital power design. It achieves high efficiency, as I said. It's up to 5 kilowatt natural convection cooling. This is some of the waveform PFC bus voltage, flying capacitor voltages, and then you have the grid voltage at 270 volts, and grid current is channel 4 showing the grid current. On the right hand side, it shows the switch node waveform, a very high slew rate, about 100 volts per nanosecond. You can see, and overshoot is still controlled with less than 25-30 volts. Efficiency on the right side, lower right side, you can see the efficiency curve is almost 99% efficient at 5 kilowatt level. Next. Okay, so that's completes my presentation, and thank you for joining.
Thank you, everybody. Just a reminder, you can go on to ti.com/NPU to get the recording at the end of the webinar. And we'll stay on for a few minutes to answer some of the questions in the chat and just answer the questions in the chat from there. So thank you, and we hope to see you next week as well.